Thank you very much. Good evening, everyone. My name's Garry Moore from Checkmate Innovation. Yeah, I last presented here about 5-6 years ago in Wet Network, so it's very nice to be back. Tonight I'm talking about from Propelair to Velocity, the evolution of air flush toilets to deliver water neutrality in the home. So first of all, quickly, what is water neutrality? Well, for every new development, total water use in the region after the development must be equal to or less than the total water use in the region before the new development, so net zero. So it's achieved through a combination of water efficiency measures for new developments, predominantly to reduce water use per person. So it was about 150 litres per person per day, target now 80. So the thing with new build as well is the requirement to retrofit existing houses to free up water for use in those new developments, so you maintain that water neutrality. So how do we currently achieve that? So two predominant ways are grey water recycling, many of them on the market, different sizes, fit in an outbuilding or basement, non-intrusive, recycle your water, use it for other things like flushing toilets with. Rainwater harvesting, quite straightforward for new build, but a bit more of involved for retrofitting in existing properties. They both work, they're both on the market and being used and installed. The prices vary, but roughly figures, 5,000 to 10,000 supplied and installed. But there is a more cost-effective alternative, which not only costs a lot less, but it doesn't use the resource rather than recycling it in the first place, which must be a better way forward. So going back to 1998, I invented the first displaced air flushing toilet. That's it in all its glory, down at WRc. I think that's where I probably first met Martin Schuler all those years ago. And it works by closing the lid, it forms a seal on the pan, and it sends air into the pan, then it can't escape and it pushes the waste out. So if you don't believe it's me, there I come, like that. And I think my biggest regret was not motorising that, because I think there was another patent in that, definitely. Yeah, so I don't know if we can get the arrow up here, the cursor. I don't know if you can see that. Is that not coming up? No, it's not coming up. Doesn't matter. So what you'll see on the drawing there, I don't think the cursor's coming up. Ah, perfect. Yeah. So what you'll see here, you have a lid. Oh, I've got a lid on the pan which forms a seal. A conventional water trap there which has water in it, and this unit here, it displaces air by moving up and down. So the linear motion air pump it worked very well, but it wasn't viable for low cost, high volume production. So off I go again to look at researching alternative compressors. So the search was on for alternative air pump, and I looked at a compressor design project under the Shell STEP programme. It's a fantastic programme. Went to Cambridge University, got a second year engineering degree student, and on a 6-week summer placement, there's Aaron. And you can tell how long ago it was, because who remembers VDUs? And who remembers YK2 compliant? But it all worked, and we set to work during the summer, and we started investigating alternative ways of generating air. So we looked at reciprocating compressors. The cost is okay, but they're too noisy and too big. The pressure was okay, and we don't need high pressure for the air flush toilets. We need low pressure and high volume, so the volume was too low, the airflow was too slow. We then looked at centrifugal washroom hand dryers, and the cost was okay and the size was okay. The airflow was okay, but the problem with hand dryers is, I don't know if you've ever done it, you might want to try it if you've got nothing to do. You go in the washroom, you put your hand straight up to the hand dryer, it just starts spinning without doing any work. They stall. So on the application of the air centrifugal pump would start under load, and it would just turn around without doing anything. So there's a higher risk of blocking the pan. And the other problem was the minimum air pressure was quite high for us. You can't really run them below 3 psi in old money, but 3 psi in a drainage system gives you pressure spikes of around 2,000 millimetres water gauge, so potentially a problem disrupting other water traps. And we also looked at car superchargers, very, very interesting, completely different characteristics. Airflow was okay, pressure was good, they're positive displacement, so they don't pre-pressurise the air. But they were too heavy and too expensive. So what we did, we liked the performance, but we looked at whether we could simplify it and make it out of plastic, so it was smaller and less expensive. And we set to work. So we basically did all the physics, analysing the physics, the stresses, the friction, the pressures, looked at all the polymers, what they were capable of doing, and we came up with a new design of rotary piston compressors, as they're termed.
Give it a chance.
And that's what pretty much went into the Propelair system moving forward. So there we did some testing of all the compressors on a drainage system, and you can tell it was so long ago I didn't have my beer gut then. But yeah, so what we found through the pressure traces was first of all looking at a conventional toilet when you flush in a drainage system. That will introduce pressure into the drainage system as well. And we see fluctuations on the negative, which will interrupt the water traps. So there's, even conventional toilets called pressure fluctuations. This was basically the supercharger design we looked at, we developed. And even with a pan pressure of only 0.75 psi, you still get a 500 millimetre water gauge peak in the drain. Now, considering here, bit of a problem. Here. Yeah, considering here 50 mil is the depth of other water traps, you don't want to disrupt them. 500 millimetres is potentially a problem, but because of the nature of these compressors delivering air in pulses, the actual energy in the pulse, there's not much energy in it, so it doesn't disrupt the water trap. So it's quite peculiar to the rotary piston compressors. And you can see water trap depletion was less than 1 millimetre, so not a problem at all. So looking at how we put that into a design that we can go to market with. And it was very design driven. So we looked at 25% commercial toilets and 75% residential. We like the look of commercial toilets. It gives us a different way in. And looking at the configuration, you have 75% of the market is predominantly close-coupled designs and 25% commercial, where the pan is back-to-wall with concealed cisterns. So that's what we did at WRc, and we got very good user acceptance, very good water savings. And these went on to go in many commercial buildings, including Arup, McDonald's, Thames Water, etc. And in 2019, 119 were installed on Exeter University to prove the drainage function on those reduced wastewater flows, and all was good. So these were the Propelair toilets that went into, that were installed. They were very good and they're proven to work in commercial environments, but they're not suitable for domestic applications because they're back-to-wall pans with concealed cisterns. You need a false wall or a cabinet for the cistern to go in. You need to touch the latch to open them. Not only do users not particularly like that, but because it's locked closed, it stops the pan acting as a spillover, so they've got a fluid category 5 rating, which means you have to have auxiliary overflows. The equipment was too large and noisy to put into dwellings. Rear exit only outlet pan means they're not suitable for bathrooms. So with the patent expiring in 2019 and me having left Propelair the year before, COVID came. And there I am, laying in my hammock having a beer, and I just thought that the air flush toilet for the residential application hasn't happened. Just started thinking about doing it, and the light bulb moment came. If I can, there we go. Yeah, and we've come up with some really good ideas about how that could happen. So, looking at the bloodline. So if we go back to the original air displacement toilet, on the left is the Propelair, the commercial application of that. And even in 2021, I saw that a cabinet version has come out. It's still back-to-wall concealed system, which isn't suitable for residential bathrooms. Whereas on the right, we've really redeveloped and gone back to the original drawing board to look, and they're completely different embodiments. Looking at how we can get all the air flush working in a close-coupled form. So I put my team together, these were some of the guys that worked on the original Propelair development, and we came up with the Velocity 1.4 litre residential toilet, the award-winning Velocity toilet. Woo! And the main differences and benefits are, so it's a close-coupled design. So it's, you know, what people are used to and expecting to see in their bathrooms, and it's aesthetically more pleasing. So it's a touch-free, normally open lid, so you haven't got that fluid category 5 rating. It's the same as a conventional toilet. So we're also looking at making the toilet self-cleaning. We're looking at chemical-free disinfectants, so it kills viruses and reduces the use of bleach which goes into the ecosystem. Completely redesigned the pan, so we've got a rear or bottom outlet pipe, which is more suitable for lots of different configurations in houses. So 1.4 litre air flush is an 85% saving on average flush volumes, and we're looking at reducing average household water use by 25% and getting to that 80 litres per person per day target. So 10 times cheaper than grey-water systems, 20 times cheaper than rainwater harvesting. We're currently technology readiness level 4, so proof of concept. We've got a very experienced development team, and we're looking at installing refined units in the University of Exeter. We've teamed up with them and South West Water. To date, we're all self-funded. We haven't had any funding from anyone. So this is us at our last AGM. We're now seeking money to move forward, whether that's grant or investment funding, so we can buy essentials like shoes and food, that sort of thing. So just winding up now, and we see the future of water neutral development is beautiful bathrooms. Velocity. Thank you very much.
Right, questions, anyone?
Hello, Natasha, Make Water Famous. I'm just curious about the loss of water from the sewage system, because I'm always heard that the water is needed to flush through. So what's the explanation from your side on that?
A lot of work was done, I think, going back to 2001 at Imperial College, and Professor David Butler did a lot of work on limiting solid transport distance in sewers, and I did a lot of work at WRC on the WAND programme for about 5 years. We really studied that in some detail. There's some interesting physics and mechanisms going on. And if you remember my slide about the Exeter University, it's a small town scale trial, and we haven't found that basically the volume of water isn't directly linked to the function. There's lots of other things going on. Mechanisms of movement isn't just necessarily related to volume. Where we have encountered problematic drains or sewers, where there has been an existing problem, we've overcome that with collective flows. So that could be a siphon tank or a flush tank. So you're not actually using any more water, you're using the same amount, but you're just getting the whole system working properly. So the whole point of the Horizon 2020 project in 2019 was to install across, I think it was about 8 or 9 buildings at University of Essex, and really study that in some detail over 6 months. We found that there was no detrimental effect on sewer function.
Yeah, thank you for a great presentation and taking us on that really long journey. I really enjoyed that. So obviously there's lots of staying power there, so Garry, thank you for that. I'm looking at this photo or image on the screen now, and obviously it looks hugely desirable. It looks conventional. What sort of price point are you aiming for when you go into production compared to conventional?
So we're looking at hitting the market at sub £500. So have a payback in 3 to 5 years is what we're aiming for. So it's in the kind of mid to nice range of what you get in a bathroom showroom now. So the ability to pay for itself is one key, but of course giving a massive cost benefit over grey water and rainwater harvesting is another benefit.
So I'm curious, how can we help, Garry? I can't install these at WRC because they're for residential, and I have wall-hung toilets in my house, so I can offer my mum's house to you. But what else can we do as an industry, as the people here?
It's great. So what we're looking to do with Exeter and South West Water, we're looking at really getting them in places where we can demonstrate the technology, we can show them. And putting them in houses is great, but we can't get people going in there seeing them and showing what they can do. And one of the big problems is people not understanding the technology. And as Martin said, it looks normal. It works differently, but you use it in a very normal way. We've got an infrared sensor on the top. You just wave your hand, the lid lifts up and closes. So we really need to look at bringing partners in and looking at identifying trial sites and really looking at bringing some funding in as well. So the awards and the exposure is really great, and letting people know what we're doing and bringing the partners in. That's probably the best help that we could hope for at the moment.
Thank you. Any further? No? Thank you, Garry.
Thank you very much.
Next one.